Okay, so we did the example 2. Now, there are 2 questions there, and I don't remember if we did both of them. Let's take a look here. We did the part on recording. Okay. So we had the equation A equals A naught times 1/2 to the, what was the rest of the equation? T over H. And you remember what those stood for, correct? The T stands for the time, the H stands for the half-life, and what does the A naught or A sub 0 stand for? Initial amount. Good. What does the A stand for? Your final amount. Excellent. So let's look at this second question right here. How much of the one, no, we did that one. Let's look at the one that's underlined here now in red. After how many years will it take 100 grams of Pu-239 to decay to 25 grams? What goes where? The 100 goes with the A naught because that's your initial amount. Okay, now this question has nothing to do with the second question. We know this is a half. How many years will it take 100 grams, so we've got the 100, to decay to 25 grams? What's the 25 grams going to represent? Our final amount. Good, so the 25 is going to go here. Now, what are we looking for? The number of years. So don't start. Are we looking for T or are we looking for H? We're looking for T. So what is H? H is the half-life is 24,000. Now, I'm going to show you a way to do this all on your calculator. You get the equation set up and we can put it in your calculator, okay? You ready? Do you have this written? Mr. Harden? It only happens in this class period. But for some reason, the smart board does not like us in the mornings, and I don't know why. Well, maybe that's it. Maybe he just doesn't want to do math in the morning. Okay, so we're going to go to your calculator, and I'm going to show you how you're going to type this equation in. Where's the rest of it? Now, listen, for you, if you've got anything on your screen, I want you to clear it. So just go to the very beginning of an equation, hit clear, and if you've got other equations in there, just get rid of all of them. Now what I'm going to do here is I'm going to write down what that equation was, all right? That equation was 25 equals 100 times 1/2 to the T over 24,000, right? Now, so let's talk about how to put this in the calculator. You know how to put that in the calculator, right? I want you to put that I circled in red in your Y1. Go ahead. Just put X. Just put X over 24,000. So make it look like that. Can you make it do that? Now, what we want to know is when is that equal to 25? So I want you to go down to the second equation And I just want you to type in 25. Now what I'm looking for is, when are those two equations equal? When do they cross? That's what I'm going to be looking for, is when do they cross? Now, the tough thing is, how do you set your window? And I promise you Mr. Harden can help you with this after I'm gone, okay? It sounds like I'm dying. I promise. I don't plan to. Now, on your time, can time be negative? No. Now, does time represent x or y in these equations? Time is x. Time cannot be negative. So you're going to make your x minimum be 0. Now, I don't know how much time. I honest to goodness don't. So here's what I'm going to guess. We're talking about years, right? And we're talking about a half-life of 24,000 years.
40.
You want to go out to 40,000? All right, fine. 40,000. Now remember, that scale says if it's 1, I'm going to count from 0 to 40,000 by 1s. So that's how often I'm going to have a little tick mark.
You do it by 25. Or 5.
I would probably do it by 5,000. Because what that means is I'm going to have a tick mark every 5,000. Okay? So I'd have a tick mark at 5,000, at 10,000, at 15,000, like that. Now your y. Your y is the amount in grams. I can't have a negative amount. So make that y min 0. Now I want you to think about this. How many grams am I looking for? I want to know when that number of grams is 25. You need to go past 25. So you could go to 50. You bet. If you want to go to 50, that'll be fine. Now listen, if you just say I've got to go past 25, don't go to 26. At least go to 30. Now again, you're telling the calculator you want to make a tick mark from 0 to 50 every 1. You want every 10 would be fine. We could do that. Now we'll graph. What do you see? Do you see an intersection? No, but do you see where one ought to be? So how are we going to make the calculator go farther out here? Make your x max bigger. That's right. So go back to your window. 48,000? Okay, well, why don't I just go to 50,000? See how that'll work. Bingo! That'll work. Has everybody got a picture like this on your calculator? Now just graph. We want to go after that point. We want to know, what is that point? Do you know how to find an intersection point on the calculator? If you know, go find it. If you don't, walk through it with me. Second, trace, which gives you that calc. Intersect, which is option 5. You'll have a cursor somewhere, and your question says first curve. Is that one of the equations that you're working with? Yep, hit enter. Second curve, is that the other curve you're working with? Yep, hit enter. Now where it says guess, just arrow over. I don't know why my little doodad stayed right there. Did you get it? Look at there. Look at there. When will that 100 grams of Pu whatever, plutonium, decay to 25 grams? In 48,000 years. So, after how many years? you're going to write a sentence, and you're going to say something to the effect of, you got to get something to write with. 100 grams will decay to 525 grams in 48,000 years. If you can get the equation set up, then you go to your calculator and do the work there. Questions? Let's go back to the one that apparently I skipped, which I believe was this one. Is that right? Okay, so let's go back there. The rate at which a liquid vitamin breaks down in the average human body can be modeled by that equation where Y is the milliliters of the original dose D. Say that again. Where Y milliliters of the original dose D remains after X minutes. So this is how much is left after that many minutes. Okay? What does the D stand for? The amount, the original amount. Yep. All right, let's put it in. Let's write an equation. What do we want to know? How long will it take for an original dose of 15 milliliters to be reduced to less than 5? Just set up your equation so that it equals 5. And then we'll say whatever time that is, we'll say after that. Okay? Here's our equation. What are we going to say? How long will it take? So what are we looking for? Time. So what variable are we looking for? T, or in this case, X. All right, so we're looking for X. What are we going to put in for D? 15 is D. So 15 times 0.95 to the X. And we want to know when that is less than 5. So we're just going to say 5, because remember, we can't say 4.9. We can say 4.99 or 999. Well, that's not going to work either. I taught you Friday how to do this with a logarithm. Let me teach you today how to just put the dang thing in your calculator. Now we're going to do this one just like we did the last one. You're going to put this in an equation. You're going to put this in an equation. And we're going to set a window to figure out where they intersect. I already forgot the equation. Where is it? 0.95. 0.95. Shows where my memory is going, doesn't it? To the X. And this is 5. Folks, the hardest thing is the window. What does X stand for? Time. Can time be negative? No. X is measured in, what did it say? No, the time. Time is measured in what? Minutes. So I want to know how many minutes. Well, I don't know how many minutes. But I bet it's not 50,000 minutes. You want to try 100 minutes? What's that, a little more than an hour and a half? What scale do you want to, how do you want tick marks if you're going to count from 0 to 100? 10? 10 will work. I think that's a good one. What does Y represent here? No, X is time. What's your Y value represent? The amount, right. It's the amount of in milliliters of the medicine. I cannot have negative amount of medicine, so I'm going to let Y min be 0. What amount of medicine am I concerned about? I want to know when the amount of medicine is less than 5, so go bigger than 5. 10 will work. 7, 8, but don't go 6. Go higher than that. We're going to count from 0 to 10 and put tick marks every one. You can do 2, yeah. There we go. That's pretty. Oh, that went right through a little bit there. Find the intersection. Come on. Let's round to the nearest hundredth. 21.42 what? Minutes. 21.42 minutes. Now listen. 21.42 minutes is when there is. Oh, now that was interesting. Look there. No, I didn't mean to. Like, anyway. Goodbye. It's equal to 5. Right. So we're going to say after that many minutes, there will be less than 5. Does that make sense?
Yeah. So in your sentence, would you just say after 21.42 minutes?
Yes. After 21.42 minutes, there will be less than 5 grams. You can abbreviate grams with G. That's how you do it in science. You're right. This is milliliters. My bad. It's liquid, wasn't it? Thank you. Let me see here. Okay, so these problems were back on half-life, correct? Okay, here we go. A doctor prescribed, any of you thinking about medical school? Do you know that if you prescribe the wrong dosage for a patient, they could die? You got to know a little math because you better know how to prescribe the right dosage. You're right, it's not that hard, but here we go. A doctor prescribed a daily 15 milligram dose of vitamin D to a 55-year-old man. The man weighs 225 pounds. The half-life of vitamin D is about 25 days. Find the number of days to the nearest day that it takes for the initial dose to drop below 9 milligrams. I want you to set up an equation for that one. It's half-life. So you're going to have A equals A naught times 1/2 to the T over H. Write an equation. To the what? T over 25? And that equals, we want to know 9. But remember, we're going to have to, below, so we're going to have to use what word in our answer? After. After. Okay. Let's put this in your calculator real quick. 15 times 1/2 to the T over 25. 15 times 1/2 to the T over, oh snap, I didn't want to do that. And 9, I believe. You got that in? Okay, let's go to your window. We're talking about days, correct? Can't have a negative number of days, so x min is 0. What do you want x max to be? Days. 10 days? All right, we can try 10. I'll count from 0 to 10 by 2's would be fine. 2's would be fine. What does y stand for? The amount. What amount do I want to see? 9, so go bigger, maybe 15 or 20. Oops, not there. Bless you. 20. Might count by twos. You got your window? Up. What do I need to change? X max. I'll double it. There we go. Go ahead and find it. Bless you again.
You just click enter.
You sure can. Guys, you really don't have to do this guess part. You can just hit enter when guess comes up.
So 18.
Yep. So after, there will be less than 9, was it milligrams?
Yeah.
There will be less than 9 milligrams after, what did we say, 18.42 days? Are you understanding? Don't mess with me here. Are you understanding those okay?
Yeah.
Listen, because I don't have a lot more time, for now I'm going to skip C.
Yeah.
Right here. Right here. So, any of you in the market for a new truck? Anybody would like to have a new truck? Okay, so Manny would like to have a new truck. Manny wants one of those that's, I mean, it is decked out. It's got every bell and whistle. It's got that tailgate that does the extra little unfold things. Okay, that's so cool, right? I've seen them. Those run about $70,000.
It's pretty cheap.
Is it?
Pocket change.
Maybe in your pocket, not in mine. When Manny drives that truck off the lot, is it still worth $70,000? No. It depreciates. It lowers in value. Okay? Now, you learned that in QL. Is that what you said? Okay, good. Now, there are things, however, that increase in value. Hopefully the house you live in is increasing in value. Jeeps decrease in value, but not nearly as much as most everything else.
2 cents every 20 years.
Yeah, not the, we're talking about the Wrangler, the traditional Jeep, not the Cherokees and those, but yeah, you're right about that. Your house, hopefully the house you live in is worth more now than when your parents bought it. Okay, that's called appreciate. It gains in value.
What?
I'm not even going to comment because I don't even know what to say. Okay. You can model growth or decay by a constant percent increase or decrease with this formula. Now, here's what I want you to know. First of all, I have to get back to it. Let's just say that truck of Manny's depreciates by 5% a year. I'm going to if his truck depreciates by 5% a year, then we would use the.
Whoa.
It sure was. I'm going to keep it right there. Then we would. No, I don't want to keep it right there. I want to go. Am I going to the next page? Or? I don't know where I am. I really don't know where. Okay. If Manny's truck is going to depreciate in value, then I'll use the minus. Okay. If it's going to depreciate by 5% a year, then right here, I'm going to put 5% written as a decimal. Does that make sense? The 70,000, the original price is going to go right there. And the value of the truck after a certain number of years would be right there. So let's just look through this. You write these down. I really would like to cry sometimes with this stupid thing. That's the wrong one.
You got 5 minutes.
I've never been to Bentonville West, so I really can't tell
30
you.
minutes, and then what time should they start?
Is it? We're leaving here at 9:30, so don't ask me. I'm just, I'll get out of the car when they stop and tell me to get out. Mr. Lindley's driving, so I'll get out when he says get out. So, okay, fine. So, put these down. Put these down. Okay, you ready? Okay, so we're going to go down. Tony purchased a rare 1959 Gibson Les Paul guitar. They
Pretty.
in 2000 for $12,000. Experts estimate that its value will increase by 14% a year. If that's true, holy mackerel, he's got a diamond. Okay, when will the value of the guitar be $60,000? All right, we're going back to this equation. Now, think. Not today. Not today. All right. What is the initial amount? What's the initial value? And that's what he bought it for. 12,000 times 1. Now, am I going to use plus or minus? Plus, because the guitar is supposed to increase in value. How do I write 14% as a decimal? 0.14. Because when will the value of the guitar, so I'm looking for time. Now listen to me. Because we're out of time, I just want to talk you through this. How do you put this in your calculator to solve it? The same way you've been doing. Exactly the same way. So let's not do that. Let's go on and let's set up a couple more before I have to leave. Here's the truck. Now, the value of a truck bought new for $28,000, that's called no bells and whistles, right? Decreases by 9.5% a year. When will the value of the truck fall to $5,000? All right, let's do our, am I going to use plus or minus? Minus. Ah! I think it's probably giving me a sign. There's your sign. There's your sign. I love Jeff Foxworthy. I think he's hilarious. What's A naught? 20.
It's over.
It ain't over till it's over, honey. 28,000.
How do you know it's over?
1 minus what?
9.5.
How do I write that as a decimal? How far do I move the decimal? 2 places. So where's that decimal going to go? 0.095 to the T. When will the value of the truck fall to $5,000? You're going to put that in just like we've been putting them in. Do you have questions? Okay, I'm going to stop. Question. Do you know what percent means? Percent? No, it's a good question. But no, you asked, I'm going to tell you. Percent means out of 100, because how many cents are in a dollar? 100. So out of 100, 100 is 2 decimal places because 100 has 2 zeros. That's why you move it 2 decimal places. You're like, I didn't want to know that. Well, you got it anyway. Okay. I'm going to give you your assignment. You ought to be able to get the whole thing done before you walk out of here today. Okay? Answer key's up here. Now listen to me. Mr. Harden, it's still so hard for me to call you Mr. Harden. Mr. Harden, he knows this. He will take care of you. You just ask him, okay? And I'm sure he'll have a joke in there every now and then if you want one. Six, seven, 8, 9. 6, 7, 8, 9.
Oh, God.
4, 5, 6, 7, 8. There we go.
This stretched too